Uh, I want to show you guys a couple more curve fitting tricks that we didn't have time for last time. And I've thought long and hard about the fact that you guys took way longer on the activity last week than I wanted you to. And I'm going to do a thing that I never do. And I'm going to go ahead and punt the activity for this week and give you an extension for what we started last week. So there's two of you who've already turned in that lab report. So if you're one of those two, you get a week off. Good job. Although you might want to reconsider, because I've looked at a couple of those bits, and some of some of your data taking was kind of sloppy, and you've come to some conclusions that are not well warranted. So if you've already turned it in, you might want to double check your work, because something's not right when I'm looking at your results.
Wait, I'm sorry. You said, wait, you're talking about the actual lab report?
Yes, the lab report that was due like a minute ago. I'm extending that until next week, and I'm gonna give you another week to work on it. Before I let you guys talk amongst yourselves, there is a trick that I'd like to introduce you guys to that we should have probably done last week, but we didn't really. I didn't want to spend that much time. And it's a trick that gets used a lot for figuring out equations when you're not sure what you're dealing with. And some of you guys ran into it a little bit with objectives 1 and 2 on the pre-lab exercises. And the issue is that when you're fitting a curve, a lot of functions give you graphs that are sort of curvy, right? Parabolas are curvy, cubics are curvy, quartics are curvy. All of those things have like weird curvatures, and it's hard to tell the difference between, say, a parabola or an exponential. And sometimes you need a little heads up in terms of figuring out what you're dealing with, because you know it's curvy and you're not sure what the curviness is. And there's a trick that physicists will often use in order to discriminate between one kind of curvy graph and another kind of curvy graph, so they can figure out what's the real physics behind it. And I want to address that sort of trick because we use it in this class a lot. So let me switch to my camera real quick.
This is easy to easily figure out how to figure out the equations for the actual site.
Right. The idea is that you've got some data and you don't know what the equation is, but you'd like to figure it out. So it turns out the camera works better when I plug it in. Ha ha ha. Yo estoy muy estúpido. All right, let's see if that works any better. Turn it on. It's warmed up. I said I thought it was warmed up. Stop flashing. Nope. Come on.
You're on mute.
We can't hear you.
Yeah, I think you're on mute.
We still can't hear you.
Oh.
Testing, testing, testing.
You're good.
Okay, cool. When I plugged in the document camera, it tried to switch microphones on me, and that was a problem. All right. So when we're plotting data, let's go back to my shared camera for a second. So you've got some data, and it's curvy. And the problem is you look at something curvy like this and you think, man, maybe it's some kind of parabola, something with like an x squared in it. Maybe times something You know, that could be an explanation for data that looks like this. But maybe instead it's y equals, well, sorry, that would be positive. So some e to the some kind of power of x that's positive, that could also be curvy like this. You know, it could be any number of different things. It could be, you know, y equals ax to the 5th power for all I know. Any one of those could end up looking like this sort of graph. And I'd like to be able to figure out what it is without having to make guesses, because it turns out that if I guess one of these things wrong, it's entirely possible that I may end up finding a workable value of these constants that makes it look like it might be a good fit, but maybe it's not. And so there's a trick that we often use in physics when fitting curves. And that trick is to plot graphs in such a way that they're no longer curvy. I want to be creative in how I plot my graph so that when I plot my graph, I get a straight line. And with any number of these, you can often pull that off if you plot it in a way that makes sense. So for instance, let's imagine that I have reason to believe that this is what my graph is. I think that it's y equals something times x to the 5th. Maybe there's a theory that suggests that that might be the answer, and I want to test that theory. Well, here's what I can do. And I'm going to switch shares to an Excel file. And we'll do some analysis and try to make sense. God, I have too many tabs open. All right. So I'm going to open up an Excel file real quick. And I'm going to generate some fake data that looks like that sort of fake data. And I'm going to show you how this trick will play out. So I'm making up some x's. I'm going to make up some y's. Let's have my x's start at 0 and go up by 0.5 each time. So yada, yada, yada. All right, a whole bunch of x's. And let's have my y's be of the form 4.65 or 56 times x raised to the 5th power. So I know what the answer is because I'm making this data up. But if I was doing the experiments, I wouldn't necessarily know where all these numbers come from. I would just have to make guesses based on the curve. Now, when I plot these values, let's insert a graph real quick. There's my graph, right? And you had data last week that kind of looked like this. And I'm looking at this, and I can see that it's curving upward. I can see that it's sort of flat. It takes off a lot eventually. That's maybe a hint that it's a polynomial whose degree is probably one of the larger numbers, you know, probably bigger than x squared, because the higher the upper order is going to be, the flatter that bottom part is going to be, and the sharper the takeoff will be at the end. But even then, if I didn't already know that I'd used x to the 5th, I would be at a loss for guessing. However, if I'm clever, I can take this data and I can plot it in a way that is going to make it a straight line. And here's the trick, right? Let's cut this and paste it up closer to the top. All right. So here's what I'm going to do. If I've got, let's go back to my camera here. If I think that this is the answer, obviously plotting y as my y-axis and x as my x-axis is going to give me this kind of curvy graph, and I don't want that. However, if I redefine what it is that I'm plotting, I can maybe get around this, because what if instead of having x be my x variable, what if I just replace it with x to the fifth? What if I treat this entire thing like the x coordinate? And I'll leave y alone. So what's going to happen is I'm going to have y equals some number times x, where x is something more complicated. Well, that's what a straight line would look like. It's going to be y times a slope times whatever your x variable is plus b, which apparently is 0. So watch what happens when I make that sort of adjustment. Right? I'm going to go back to my data. And I'm just going to copy my x's over to the side real quick so I have room to work. But what I'm going to do is I'm going to take, for my y column, I'm going to type y to the fifth. Or x to the fifth, excuse me. So the idea is I think that my y variable is varying with the fifth power of x, not the first power of x. So what I'm going to do is I am going to take, oh, hello, backwards. Oops, not that much. I want to recopy this column. There we go. So I'm leaving my y's alone. Oops, Control Z. I want to paste just the values. There we go. But what I want to plot as my x-axis isn't x, but rather x to the fifth power. There we go. So now this, I'm just going to take whatever value of x I had and raise it to the fifth power. Now, obviously, 0 to the fifth power is still 0. But when I drag this down, what's going to happen is x to the fifth power is going to end up being a much bigger number than x to the first power, right? It goes from 0 to this. And by the time I get down here to 5.5, well, 5.5 to the fifth power is like 5,000 and something. So now what I'm going to do is I'm going to make a graph of this stuff. I'm taking the x values and replacing them with x to the fifth power, and I'm leaving my y values alone. So now I'm going to make a, what's going on here? Let's try that again. Made some kind of weird click there. So now I'm plotting this graph, and you'll see that when I plot this graph, where the x coordinate is x to the fifth power instead of just regular x, and the y coordinate is the same as before, what used to be a very curvy graph has turned out to be a straight line. And what's more, now that I take that straight line, if I put a trend line on it, since it's linear, it's super easy. You can see the slope of that trend line is 4.56, which when I made up all this data, you can see that it was 4.56 times x to the fifth power. So by taking my annoying curvy graph and plotting it in just the right way, I can end up with a straight line. And the thing about curvy lines is they all kind of look very similar. It's hard to tell them apart, but straight lines are obvious. And so we'll often plot things in such a way that they're straight. We actually used this trick a few weeks back when we did the Kepler's Law Lab. Right? If you recall, during the Kepler's Law Lab, you had Kepler's third law, which said that r cubed over t squared equal, was it gm over 4 pi squared? And if I rearrange this to get t by itself, I have t squared equals what is it? 4 pi squared over GMR cubed, right? So this was the formula that we figured our data about the planets and their orbits would represent. And so when we did that graph, what we did was, since this is by itself, I called this my y coordinate, and I plotted t squared on the y-axis. Since this is my other variable, I put r cubed on the x-axis. And as a consequence, we got a straight line, the slope of which was this. And by looking at that slope, you could tell whether or not Kepler's third law was being obeyed. So it's a trick that we're going to end up using a lot, and it's super, super helpful if you've got some sort of guess about what the function might be. If you plot it in just the right way, you'll end up getting some sort of linear function. You know, if I had a function that was, like for instance, in my physics 2 class this week, they did a lab on Snell's law. And Snell's law, which we'll learn next semester, is this. And don't worry too much about what all this means. We'll learn it next semester. But what's going to happen is they did an experiment, and in their experiment, they could measure this, they could measure this, they could measure this, but they were trying to prove this law, and at the same time, they were trying to figure out this. And so what they did was they set up their experiment where they kept changing this, and they kept changing this. So their variables were the two thetas. This was a constant that never changed, and this was the thing they were trying to figure out. And what they would do is they'd rearrange the equation.
Wait a minute, aren't you trying to get N2 by itself?
Well, except they're trying to do two things. They're trying to figure out N2, and at the same time, they're trying to prove this equation. So just using the equation and getting a number doesn't do the second part. Does that make sense? But by proving the relationship looks right on the graph, they'll be able to do both things. So what they did is they rearranged the equation, and then they made a graph. Now, if they made a graph where theta 2 was one angle and theta 1 was the other angle, they'd get some kind of annoying curve. This sucks. Instead, what they did is they said, aha, this thing over here, we're going to call that y. So whatever they had for theta, they take the sine of that theta and they plot the sine of whatever that theta was as their y-axis. Then they do the same thing with theta 2. They take theta 2, take the sine of it, and plot that number on their x-axis. And when they did that, what they ended up with is a perfectly straight line, the slope of which was this. And of course, if you can plot the line, measure the slope, and if you know what N1 is, you can figure out what N2 was. And so that's how they performed the problem. So no matter how ugly or weird looking the equation is, if you plot it in a clever way, you end up with straight lines. And that's the thing that we rely on so many times in physics.
Just to clarify, you said we don't need this for the lab, this equation?
No. This is just an example of how you might plot an equation creatively.
Okay.
Right? So you're not going to use this equation. You're not going to need to know this equation until the very, very end of physics 2. But the point is, it's a weird equation with lots of signs in it, which you wouldn't expect to be very straight. Sines are generally weird curvy graphs, right? But if you plot it carefully in just the right way, you end up with something linear. And that's what we're exploiting. So if I thought that, y equaled e to the negative x, then what I could do is, instead of plotting x, I could plot e to the negative x as the x-axis, and this is the y-axis, I'd get a slope of 1, but the line would be straight. So if you have a guess of what the function is, sometimes you can pick how to graph it in a way that makes it a straight line. And that's a trick that you might end up using on a couple of those examples to get better results from your data. It's also going to be very helpful when you do the actual lab part of this week's lab, because several of your graphs, when you do, for instance, the period of your pendulum as a function of the length, then what I expect your data to look like is this, right? What do I think that function is? If I had to guess what that function was, what would it be? We don't know. We've slept since then.
Can you repeat your question? I'm sorry.
So when you do the pendulum lab, right, for this week, with carried over from last week, most of you haven't done it yet. When you take your pendulum data and you look at the period of the pendulum as a function of length, your data is going to end up looking like this. This is what I expect to see when I see that data. Looking at a data in that shape, what do I guess the equation might be?
It looks like a parabola, so
But parabolas would open upward or open downward. So it's like a parabola that's sideways.
oh right.
So what's a sideways parabola suggest? We talked about it last week, but you may have forgotten since then. Parabolas are x squareds. Sideways parabolas are square roots. So I might think that t is equal to something like the square root of L or something like that. Maybe it's something times the square root of L. Now, if that was my guess and I wanted to plot this data in a way that gave me a straight line, how could I do it? What could I make my axes to make that turn out to be a straight line? I'll make this be the y, because y is always the variable that's by itself. And then instead of having L be my x variable, I'm going to take the whole square root of L and make that be my x variable. And if this is a correct guess, when I do t versus the square root of L, I should get a straight line. If I get a line that's still not straight, that suggests that maybe this guess was not correct and it's some other function that makes sideways parabola looking things. But if it turns out to be straight, then that's probably a good guess. All right, so at this point, talk amongst yourselves. If you need additional time, I'm here. Otherwise, have a good week. If you need to put you in groups, I will put you in groups.
Wait, I have a question. Are you still gonna be here till 3?
I'll be here till whatever.
And also, we're doing the lab from last.
Correct.
lab.
You're finishing up the last week's lab because many of you have not, like you at the end of the lab period last time, many of you had barely done the pre-lab exercises and hadn't done the lab itself. So
Right.
I didn't want you to have to do that without any guidance. So I want to set aside this time so that I'm available to help you with that.
Right.
If you don't need that time, then I don't know, go do whatever it is you guys do when you're not in class. Maybe homework. But otherwise, you know, I'm not going to make you do a separate lab and then do the other one as well. So
Oh, right. Okay, so we're just doing lab from last class.
you're finishing up the lab from last class. If you've already finished, go away. If you need more time, then use it. I'm here for you. But that's what
Oh,
we
well,
got.
can you set up a breakout room or whatever?
If you need a breakout room, I will set up some rooms now and put you wherever you guys need to be. But
Okay.
who do I need to put where?
Can you put Amber Ryan, Taylor, and Gia in one group in a breakout room?
Yep.
Thank you.
Yep. You're room 1. Anybody else need a room?
Please.
Can you be more specific?
Move.
All right. Who else am I assigning to places?
Can me, Brittany, and Jerry and Bree get a breakout room?
So you, Brittany, Jerry, and Brianna. I'm assigning to room 2.
I guess me and Kayla.
Okay. Kayla's already turned hers in, so
Can I join that group? Because I have some questions from last week.
yeah, I'll put you guys in room 3. And Jesus, I see you'd already turned yours in.
Yeah,
You're good to go.
I think I might need to revisit it.
It wouldn't hurt. Yours was not the one that was particularly bad. One of the ones that got turned in, like when I looked at their mass independence, they had it depending on the mass, and I'm like, no, that shouldn't be the case. So if they were getting a mass slope, that suggests they were doing something wacky with their setup.
I gotcha.
That's definitely not how it works. But you had yours mass independent, which is exactly what I expect.
So, did we just have to give like a general idea of what the function was, or like
The more specific you can be, the better. So, like, for instance, I believe that you successfully identified that the length was a square root function.
Right.
So fit the function. Tell me what the function is, because it turns out it'll be t equals something times the square root, and what that something is might be the subject of theory. So being able to pin down the specific number, which I don't recall that you did, would be helpful.
Okay. And we do that similar to what we did in pre-lab last week.
Yes.
Okay. Could I get a room in the meantime?
Absolutely. I will throw you into room number 4. I don't want to go into room 4. I'm putting you there. And Wendy's usually with you, right? Quez,
Yeah.
are you usually in a group, dude?
Yeah, but I'm working solo.
Okay, that's cool. You can do that, whatever. I'm here for questions.
Are you also here by email?
I mean, my emails will ping.
Gotcha.
Yeah, like when I have like office hours, I usually have my computer open so that if I get emails, I can see them. So, one thing I would suggest if you're sending me emails, if you send the emails directly, I get them faster than if you send them through Canvas. I've discovered that, like if you use the Canvas email your professor thing, it takes a while for that to migrate to me. It's very annoying, but if you send it directly, I'll get it much more quickly.
Okay. You offering during the summer?
What's that?
Offering during the.
I believe we're offering physics 1 and 2 during the summer, but I'm gonna have to double check on that. I think that was what was on the schedule. That was made before the decision to go full online was, and I haven't looked at the enrollment lately, so I'm not sure if either of those are gonna end up making. But if the students are there, I'll teach them both.
Question: how do you think it'll turn out for the online session?
Well, it'll be different. One of the things that I've discovered, just since we've come back from spring break, is that there are some students who were doing kind of okay before the break, and they've adapted pretty quickly. But there's other students who are maybe on the borderline, and what's happened is they're still not reaching out for help, and I can't help you unless you're making yourself available. So I do worry that it's going to be harder for students who might have otherwise struggled to get the help that they need, because there's not the same sort of structure. So I don't know. I think it'll go okay. It'll go. I hadn't taught online before, and there's a couple things that I'll have set up differently for the summer than I had here, just because we've had the prep for it. But I think it's doable. It's we're gonna work with what we got.
Okay. Well, my next question is that pass and fail is still an option. The pass.
Absolutely.
Okay.
The deadline for that, you have to make the request before, I believe it's the 29th.
Will do.
And all you've got to do is you'll send the request to me in writing saying, hey, I'd like to switch to pass fail grading. And I'll respond. And, once you make that decision, you can't back out. So it's final. You got to, don't pull the trigger on that unless you really mean it. But especially if you're worried about, maybe not passing.
But and it just bring GPA even lower. So I'm just like,
yeah, you might as well. If you're worried about not passing, I would probably take it, because it's better to not take the GPA hit. If you're thinking you're going to do well and it'll pull your GPA up, then it's a bad thing to pick, right? Because it won't help you if you pass, but it won't hurt you if you fail. All right, I'm being beckoned to a room, so I'm going to go see what those guys need.
You're fine.
All right.